Over 3 billion people rely on the oceans, whether it's for food, recreation, or transportation. These services are especially important to undeveloped communities, many of which have little access to other sources of income. Now more than ever, the ocean is negatively affected by harmful algal blooms, also called HABs. HABs are a rapid growth of algae or plant matter, often due to high nutrient availability, and that could be toxic to the environment. Think about it this way. Sugar is fine in moderation, but bad for your teeth and overall health if you have too much. In the same way, too many nutrients can cause supercharged growth of algae, which is bad for the ocean's health. This is especially true when all the algae dies because it takes up a lot of oxygen as it decomposes. This is what leads to something called dead zones, areas where very little oxygen exists, which results in animals moving or dying. On top of that, some of these HAB species produce toxins. When they bloom, the toxins they release into the water can impact the seafood that humans eat. It can also mean that the places where we rely on ocean resources are no longer safe. HABs are becoming worse and more common as the conditions that are causing them expand. As a response, many countries have management and monitoring programs to reduce health dangers. However, a lot of communities that are vulnerable to HABs don't have the necessary resources to manage this threat. This is critical because they are likely to depend on their local ocean's resources. My project aims to help these communities with computer simulations and artificial intelligence. We paired information on HABs across the world with data from satellites that give us insight into conditions at the ocean's surface and seafloor. Then we use computer simulations and artificial intelligence to figure out how well HAB species can survive depending on their local environment. With that, we can predict where HAB species will exist now and in the future. By developing forecasts, we can help communities focus their limited resources on effective species-specific management strategies. That way, they can protect themselves and their natural resources from this growing threat.